are you talking about?
I don't know. I feel that
Like it was on your schedule? It was on your that was on your planner? Okay. So for the millions of Twitch fans, this will I guess you'll have to maybe just listen mostly to this because I'll write some stuff on the board, but a lot of it's gonna be you guys you might need to pull this up on your own screen.
Just didn't even tell me.
I want to close the
to
blinds.
sign it.
Close the blinds.
So she did, like, call my house, he's like, this could be fake. I was like,
You can
what?
see it? Yeah. If you need a second to grab a computer so you can have it in front of you, that's fine too. Either you need a second. While you're getting ready, I'll just read the first one. So the first one just says, if a wheel of 2 meter radius is spinning and makes 40 revolutions over an 8-second period, what was its average angular velocity? So this test, I mean, in my opinion, this is actually a vocabulary test. Now it's a bit more involved than your little matchy vocab test, but it's still like this question. If you know what those mean, then it's pretty straightforward, right? So you have a wheel. So you do have a note card for this. So my advice on any given question might be to draw a little picture. So it's a 2 meter radius wheel. What is it spinning? What is it? 40? Now, what does it mean if you say 40 revolutions over how long of a period? It's a glare. It literally just looks like a white sheet. Okay, over 8 seconds, right? So you guys know what that means. So that's 5 revolutions per second, right? Now, what letter is that? What word is that?
Frequency.
That's frequency. You feel okay about that? But the question's asking, what's the angular velocity? What's the angular velocity? Well, what letter is that? The omega. It's omega. Fancy W, Greek W. Now you got your note cards, so you know. I'm just going to put them at the top here. One thing we know is that omega is 2 pi multiplied by the frequency. Okay? That's a big leap formula. So the answer to this is 10 pi radians per second. Okay? Easy peasy? We're able to get your thing pulled up?
Yeah, I can see a lot of the screen.
Okay. But are we okay with that? Yep. Okay. So if it was me and I was still a little shaky on this stuff, I'd probably have a little labeled, I might make a list. Omega represents angular velocity, right? And then what are the units of angular velocity? Radians per second. Right, that's just one example. You could have a list of like what each letter is. F means frequency, that's revolutions per second. Or what's the fancy unit for revolutions per second? Hertz. Like in the American classic television show Doug, Roger Klotz would sometimes say to Doug, "Would you like a Hertz donut?" And then when Doug said yes, he would punch him. Say, "Hertz donut, Hertz donut." That's for you, Caleb. That's a big movement for you.
I'll definitely do that.
I don't know if that was a reference to the unit Hertz, but it could have been.
I think it was.
He was also green. Skeeter was blue, though. Interesting. Was Patty mayonnaise? Was she just white? I think she was maybe she was yellow. You never seen that show?
No.
Oh,
What
okay,
are you
never
talking
mind.
about?
Boomer alert. Boomer alert. Doug. There's a TV show called Doug. Never mind.
I think we should watch it.
There's a superhero called Quail Man. It's actually the alter ego of Doug. And his dog was his sidekick. Anyway, where were we? Oh, by the way, one of those numbers was irrelevant. Which number? There was a red herring that had no bearing on the answer. The radius of the circle. Now, the radius of the circle definitely matters if you want to say, like, what's the velocity of some point on the circle? If I wanted to know, what's the velocity of that point, then that's very relevant, the radius. But if you just want to know about the rotational rate. It's not relevant. Okay. Number 2, a cylinder of radius 2 meters is rolling along a flat surface at a constant rate. And the cylinder travels a distance of 100 meters over a period of 5 seconds. Find the disk's angular velocity. So same procedure as always. I'm going to draw a little picture of this. There's the ball. The radius is 2 meters again. It's a big ball, or cylinder, I should say. It travels 100 meters at a constant rate. And that took 5 seconds. Okay, so there you go. I've listed out all the relevant information. There's a couple approaches you could take here. What's maybe anyone have an idea of the first step we could take that would get us somewhere? Divide the radius by 2 pi?
No, divide the total distance by 2 pi.
Oh.
Get a radians or no?
You could divide the distance by 4 pi to figure out how many rotations it made. There's a simpler way though. Let's go. I'm gonna show you a simpler way. Because dividing the distance by 2 pi there's no real direct connection there. I mean, there's something there, but it's not going to be very clear what it is. Anyway, what's another famous formula we're going to use in this test? V equals omega r. That's a really important one. Now that V can represent just the velocity of a rolling object, right? So things rolling, or it could be like a point on a spinning disk. So it could be like this point right here. For example, if I want to know how fast it's going, I would use the same formula if I knew omega. Okay. So here, so then which of these letters can be very obviously got from these two numbers? The velocity, right? So I know that the velocity is what? 100 divided by 5. Very good. 20 meters per second. Okay. Now, this relationship is very handy because now I can just go, no cap. Sorry. So I can write this same formula, right? 20 equals omega times r. So omega is 10 radians per second. Yeah, it's pretty easy. I don't think there might be one or two on here where we have to use that one formula, the famous formula, but other than that, they should be pretty straightforward. Keep in mind, guys, the whole point of this unit, I don't really even like doing this. Is kind of a boring one, but the whole point is that we start talking about torque and angular accelerations and stuff, that you can understand what we're talking about. What does it mean for something to have a speed of 6 pi radians per second? So the questions should be pretty straightforward. Okay, so number 3 says we got a cylinder of radius 2 meters. I don't know why they have radius of 2 meters. I don't know. It's lacking creativity, I guess. It experiences a constant angular acceleration of 4 pi radians per second squared. So what letter is that? Angular acceleration. Fishy.
Fish.
Alpha, the Greek A. So alpha is 4 pi. Now remember what that means. That means radians per second per second. So how many radians per second of velocity are you gaining every second? 4 pi. So every second you're increasing your velocity by 4 pi. And it does this, it experiences acceleration. So it goes from rest, starts at rest, and it experiences this acceleration for 5 seconds. Now, is there a formula you could use for this? Yeah. You can say your final omega is your initial omega plus alpha times time. You don't need to use that formula because you might just go, well, if I'm gaining this much speed every second for 5 seconds, I'm going to end up with 20 pi, right? And then so 20 pi is your final speed, right? This making sense or no? Okay, so if I went from 0 up to 20 pi, right? What was my average? 10 pi. So if I did an average of 10 pi radians per second for 5 seconds, that's how many total radians? 50 pi. How many spinnies is that? 25. So you have 25 revolutions. Is that the only way to do this one? No. You could have also used this formula. Starting to run out of room here, but that's okay. So the other method, you guys might prefer this method. Because this, I'm thinking now, like that was about 3 steps of work to go figure out this, and then use, maybe it's 4 steps. You figure out this, figure out it's 50 pi, then divide by 2 pi. Or couldn't I have just plugged in 0, 5, 4 pi, and 5 into this formula and gotten the radians? Do we all understand that? If you plugged in those numbers, you would have got 50 pi. Then you'd have to divide that by 2 pi. For how many turns? We cool with that? Okay. This one's very straightforward. Number 4 just says, if a disk is spinning with a frequency of 30 hertz, what is the angular velocity? Right? Maybe? So the answer is 2 pi times 30, which is 60 pi, yep. Julia, okay?
Yeah. Oh, okay.
Purple Julia was saying non-verbally. She was going, you sure you get that?
Yeah, wait. Yeah.
You just gotta identify that this 30, first of all, don't be scared by the HZ, it just means hertz. The hertz just means like cycles or rotations per second in this case, spins per second. And you just multiply F by 2 pi to get the radians. Each turn has 2 pi radians. All right, the next one. I'm gonna erase the board here so you can read that. It's if your disk is a 30 centimeter radius disk and you are spinning at a frequency of 2, what's that little K? Kilohertz. What is it? That's a lot of yeah, that's a lot. That's a lot of spins. Possible though. Okay, so here's your disk. The radius is 0.3 meters. Its frequency is 2 kilohertz. So that's 2,000 hertz. And it's asking, what's the speed of a point on the outer edge of the disk? What's the speed of? What's the, it's a little 2-stepper here. Think about that, little 2 steps. What's the first step? Very good. Step 1 is to get this. So omega would be 4,000 pi. Are we cool with that?
Mm-hmm.
And then my V is just omega times R, so 4,000 pi multiplied by 0.3, which is 1,200 pi, I think. So 1,200 pi meters per second. Now, some mean person put the answer 1,200 in there. Who did that? Was it Trenton? It's probably Trenton.
I like pi. I think I would have kept it in there.
I'm just saying, be aware. Sometimes, you know, it's like the previous one of the answers was 60, one of the answers was 60 pi. So it can be tricky to differentiate there. Okay, just make sure you're being extra careful.
1200 pi is more than 1200.
That's true. Yep, that's correct. About 3 times bigger.
Not a good view.
Yeah, it's
Is the test gonna be multiple choice or?
correcto. It's easy. Easy breezy beautiful cover girl. It's my corporate sponsor this week. Make sure you buy it. Use my code, link in bio. Number 6. So you got a roly-poly. So the roly-poly cylinder,
And radius of 3 meters.
that's a big cylinder. That's bigger. I mean, how big are those cylinders that you see on the highway? Probably not. No, those big cylinders out in the fields.
Oh, hay bales?
So you're very
Cylinders
broad
are-
right now. Are you talking like the construction cylinders?
No, the ones out in the grass.
You said on the highway.
When you're on the highway looking out at the field with the cows live, there's these big cylinders out there.
Those are hay bales, Mr. Romo.
Yeah, how big are those? That's probably it could be a 1 meter radius, I think. Not 3 meters. That's a huge cylinder. That's more, that's truly industrial. Okay, so this is all the information we have. Okay, it's rolling that fast, right? So there's one piece of information we can get super easily out of this.
Yeah.
Right, we can get omega. So we can go 24 equals omega times 3, which means, be careful, how many rotations per second is that, roughly?
Four?
I knew someone would say 4.
You got the weather.
Because 4 was the answer if it was 8 pi radians per second, right?
Oh, yeah.
8 pi is like 25-ish, right? Well, don't jump the gun here. I'm just trying to make sure we're straight on like this is about 1 and some change. Because how many radians is 1 rotation? 2 pi, which is like 6.3-ish, right? 6.28.
Yeah.
So this is like 1, I don't know, 1 1/4 or something. You feel okay about that? Yeah. Okay. So anyway, now you go, well, to get my frequency, right? Frequency is omega divided by 2 pi. So the answer, I think you said this, Aiden, is 4 over pi. 4 divided by pi, which is roughly a bit bigger than 1, right? You see why I'm trying to point out the whole, so like 8 radians per second, if you can pause for a moment and understand that that's just over 1 revolution per second, then you won't fall for the trap, for example, of thinking that's 4 rotations per second. You'll know this number is about 1. It's just a bit bigger than 1. So that just kind of doubles down on your assurance that it's correct. This is pretty straightforward, actually. We are throwing this word in, rotational period. That we haven't written that down yet. That's uppercase T, yeah. Big T. That was a grocery store in Big Timber. It was called the Big T. Interesting. Fun fact of the day. Fun. Fascinating.
That's almost the same big
Big
thing without the rest of the word timber.
Yeah.
Without timber.
Okay. The rotational period is just the reciprocal of the frequency, right? We're cool with that, right? So if you make 3 spins per second, then your period is 1/3 of a second. That kind of thing. So if your angular velocity is 10 pi, so if omega is 10 pi, which by the way, how many rotations is that per second?
Alright,
5, okay? Well, the frequency is omega over 2 pi. So the frequency is 5, which we just said that, right? And then, okay, that means the period is the reciprocal of that, 1/5. Cool beans? All right, the next one, notice in the last one, there was something irrelevant there. There was the radius does not matter, right?
no need for that.
As a rule of thumb, I mean, if there's no reference to like actual like linear velocity or displacement or acceleration, then you can pretty sure that the radius doesn't really matter. For number 8, it just basically, I mean, to trim this down to the most essential stuff, it's the period is 3. Okay, so if the period is 3, doing this mentally. If the period is 3, what's the frequency? 1/3. And if the frequency is 1/3, what's the omega? 2 pi over 3. We done.
Okay.
That was a speedy Gonzalez, right? Let's do it again. It's okay. There's no need to do them fast. I mean, I guess we got 15 minutes. We have time. Some of you guys might finish this quiz in like 15 minutes. I mean, if not though, it's totally fine. And it's sort of, you have the whole period, but just saying, like, if this stuff makes good intuitive sense to you, then some of these you might be able to do them very fast. But I'm trying to show you that if you're still having trouble understanding, which is the vast majority of people that I find, this stuff is very confusing. Just be patient, use your formulas. Anyway, what did it say? It said they told us the period was 3. So like always, I suggest writing down, what do they tell us? They told us this, and we're trying to find this. So how do I get from here to here? And by the way, I mean, you could write a single formula for this. Think about it. If you do a substitution between these, you'd have one formula. But I like to keep it simple, minimize the number of formulas. So if this is 3, and the frequency is 1/3, and then just plug that in here, so you get 2 pi times 1/3, which is 2 pi over 3. Does that clear it up for anyone who's confused? Confucius. Cylinder of radius 3 meters is rolling with a constant angular velocity of 10 radians per second. How far would he go over a period of 5 seconds? Off the bat, here, check your understanding. Does the radius matter for a question like this? If you're trying to be talking about meters, how many meters did you roll?
Oh, yeah.
Yes, the radius matters. Okay.
If we took a smaller cylinder that was rolling at the same speed for the same time, it would go shorter.
Totally correct. Yes, 100%. So let's again draw a picture and then list out what they tell us. They told us the radius. Great. The radius is 3. They told us the angular velocity. Great. The angular velocity was 10 pi or was it 10? Just 10. Not 10 pi. How many spins per second is that roughly?
Well, or 5 over 5. Yeah.
5 over pi. That's exactly how many rotations per second it is. Good. Yeah, like what's like 1.5-ish, maybe? Like a little bit more than 1.5?
Yeah.
10 divided by 6, you get the idea. So anyway, how far would it go in 5 seconds? Okay, so the time period is 5. So what you might do is go, well, I know that V equals omega R. This isn't the only way to do it, but this occurs to me as being the easiest. So they gave me omega, they gave me R. I might as well get V. So V is 30, right? And so if I go 30 meters per second for 5 seconds, I'm going to travel 150 meters. That's the answer. Cool beanies? We found that? Okay, a wheel is spinning at a frequency of 8 hertz. Here's my wheel. Initially, going 8 hertz, and after experiencing a constant angular acceleration, so we're trying to find the angular acceleration, he's going 20 hertz. And that took, the time period was 4 seconds. You all agree with the way the information is wrote?
Yeah.
Okay, so what is, I haven't written this one down yet. I sort of did. This equation here is equivalent to just writing that angular acceleration is the change in omega over time. You feel okay about that?
Yes.
So, what's this omega?
2 pi, 1/2.
Yep. So we're starting 16 pi. We ended going 40 pi. So that means my change in omega was 24 pi. And the time period was 4 seconds. So my alpha was 6 pi, radians per second per second. Again, not 6, 6 pi. Are we yes for that one? Yeah. Okay. So 11 is you got a ball, radius is 25 centimeters. It's rolling at 5 revolutions per second. It then experiences a constant angular acceleration over an 8-second period, after which it's rolling 15 revolutions per second. How far did the ball travel during that time? This one's a little bit more complicated. How do you think we're going to set this one up? Aside from just writing down the information. There's the radius, 0.25. He was initially rolling, was going 5 revolutions per second. While I'm at it, I might as well jot down, well, that's 10 pi. That seems to be more helpful, right? And then later, he's going, what was his final speed? I can't. 50, thanks. 15 revolutions per second. So that's a final omega of 30 pi. And what did this thing all took, 8 seconds? Okay. Does anyone know, we're kind of running out of time. I guess I gotta go a little bit faster. There's 2 ways to do it, right? I could use this formula, right? Figure out how many radians did he travel, and then just multiply the number of radians by the radius, and I'd be done. Right, because don't forget this one. Distance would just be, it's basically this formula, but with no time involved for displacements. Please say that rings a bell. That's the very first day that's the first thing we did actually. We studied this. Okay, so what you could go, that one I'll just leave out there. So you could go, okay, I can find the alpha value. I know the t value, and I know the omega naught value. I can just plug in omega naught, plug in t, plug in, because what's alpha? Alpha is 20 pi divided by 8. But there's an easier way. What's the average omega? 20 pi, right? Which means the average velocity is we understand? And so if that's the average velocity and it's that much time, multiply those and you get 40 pi, right?
Mhm.
Did I lose you or does that make sense? So in my opinion, just grabbing the average speed is probably the most efficient. And to me, it makes the most sense. It's, I mean, not that I trust the formula, but to me, this my feelies like this better. Okay. We're off. This is a good start to the week. Right, Julia?
Mhm.
No place you'd rather be, Julia. So she told me. Okay. 12 says a disk with a radius of 1.5 meters is initially spinning with a rotational period of 8 seconds. A motor then causes the disk to experience a constant acceleration of pi over 4 radians per second squared. How long will it take to speed the disk up to a rotational period of 2 seconds? Whew. Is this tricky? Doing that, I think it sounds tricky. The way it's worded is tricky. It's supposed to be. But if we draw it out, it's not too bad. So what's the initial state of the system? A period of 8 seconds, right? So it says initially it has a rotational period of 8 seconds. The final state of the system is a period of 2 seconds, right? And we know the acceleration is pi over 4. And what are we solving for? Time. How long will it take for this to happen? What if I just take these two period values and write them as omegas? Right? What's this guy as an omega? Well, what's the frequency for him? 1/8. Multiply the 1/8 by 2 pi. Pi over 4. Right? Not to be confused with that one. They mean different things. They just happen to be the same numerical value. How about this guy? Oh, I wrote the wrong letter. Sorry.
Okay, that's what I was.
That's initial omega. This guy, the frequency is 1/2. Do you feel okay about that? It's a quarter of the period, so it's 4 times the speed, rotation speed. Okay, so then to solve for t, it's this, right? So I say, well, pi over 4 is equal to the change in omega. I went from a quarter of a pi to a full pi, so the change was 3/4 of a pi. Do you feel okay about that? And so however you want to solve this, I mean, the pi's cancel out, multiply the t up, you have t over 4 equals 3 over 4, so t is 3. Yeah? Feel okay? Okay. Let's wrap up these last 3 real quick. So this last one, or this 13, is a ball rolling down a ramp. It was 3 seconds. Will the radius matter for this question? Yes. Because look at the answer choices. They all have meters in them. Right? So the radius is 0.4 meters. So it's at rest, and at the bottom at the top it's at rest. Then at the bottom of the ramp it's making 3 revolutions per second. Like that. What letter do you think what letter do I prefer? Probably omega, although that's not to say that. I mean, you certainly could make an argument that if the frequency is 3 here, what was the average frequency? 1.5, 1.5. And if you know the average frequency, you can multiply that by time to get the total number of turns, and multiply that by the circumference. Or, sorry, we're getting the acceleration, aren't we?
Yeah, the glare is brutal noodle.
This took 5 seconds. Sorry. Okay, so I'm solving for acceleration, right? And so we have the center of mass, and we know that just like this formula, it's also true that A equals alpha R. One of these letters is really easy to get, other than R. R is very easy to get, it's told to us. But alpha, right? What's the change in omega? 6 pi. And how much time did that take? 5 seconds. So that's alpha. And then so the acceleration is just alpha times the radius, right? And so the radius, so the answer choices seem to suggest this is a calculator question, right? Because they're all just decimals. So I take my calculator, I say, oh, okay, what's 6 times pi divided by 5 multiplied by 0.4? I'm getting about 1.5. 1.5079. And there we go. We okay with that? Questions? Is that the only way to do it? I mean, I think that's the most straightforward. You could have turned this into a velocity, maybe. That might have made more sense to you. You might have gone, well, if this is F, this is omega, meaning, here, awesome, I'll show you here. You could have said the final velocity was just that times 0.4, right? So 2.4 pi, and it's just 2.4 pi divided by 5. Okay, never mind. 14.
Wait, what was it again, Mr. Hall? The last answer?
It's 1.5.
1.5, I think.
Another, this one's asking for the angular acceleration of a ball as it rolls down a ramp. So same, I'm gonna keep my picture. Let's identify, what information do they give us in this question? Do they give us the radius? They better. 0.12 meters. They told us that it's at rest at the top of the ramp. The ramp is a 10-meter length, okay, 10 meters. And it takes 8 seconds for the ball to roll down the ramp. So the total time is 8 seconds. And what's the angular acceleration? So we have to figure out how many spins did he make? Or you could just say, well, I know the distance, right? I know, where did I write it here? Does that make sense? Okay. So however you want to do that. Like, let's say we do it this way, use this idea. So 10 is equal to the total number of radians turned times the radius. You're going to calculator for this one. 10 divided by 0.12. Does that make sense? That's the total number of radians turned. So what does that tell us? We can figure out the average rotational rate because it takes this much time to turn this many radians. So divide by 8 gets us 10.416 repeating. Does that make sense? Now, what does that tell us? If it started at rest, and that's the average, then what's the final rotational rate? Double that. So 20.8 roughly. And so long story short, I went from rest up to this final rate, and it took 20 seconds, or it took 8 seconds. So if I want the acceleration, I would just use my calculator. I times 2, divide by 8. I'm getting 2.6. Did that last step make sense?
What did you multiply by?
So I divided this by 8.
Oh, okay.
I guess what I just said was I took my calculator, I multiplied this by
Gotcha.
2, I get this, and I divided by 8 to get the. Okay. Now, is that the only way to do this problem? No, I can think of 3 or 4 ways you could do this, but to me that seems like the most straightforward. You might also, I'm thinking you could have plugged into this formula as well. You could have plugged in, once you figured out this number, the total number of radians turned, you could have plugged it in here. This is 0, and you know this is 8, so you just solve for alpha. Does that make sense too? So that's another way, maybe that makes more sense to you. Okay, last one. This is from your problem set, so if you, right, we do this exact, or did we do the tension of the rope one? I can't remember if we actually did this one in class.
We did the tension.
We did the tension of the rope.
Okay, so you have a radius of the disk. I'll admit this one's gonna be kind of fast, but we know F net equals ma, right? I'll be really fast. F net it's friction, right? Mu times mg. So mu times mg has to be bigger than mass times v squared over r. The m's cancel out, not the mu's. Sorry. The m's cancel out. Replace the v with omega r, and then just solve the inequality. Obviously, if you want the puck to remain on the platform, you want mu to be bigger than this number. You want mu to be big, high friction coefficient. So you'd end up with, I think E? Yeah, you'd end up with E. We all cool with that? So, for anyone still, the left side looks like this. I replaced the V with omega R, and then simplify. There you go. You're still okay. All right. Have a good rest of your day. Enjoy your Monday. We got them all. Yay.
Paul, can I go get breakfast and then come back up here to take my palate test?
Yes.
Thank you.